Question 14b. The population of foxes on an island is modelled by the logistic equation dy dt equals y times 1 minus y, where y is the fraction of the island's carrying capacity reached after t years. At time t equals 0, the population of foxes is estimated to be 1/4 of the island's carrying capacity. Part 1. Use the substitution y equals 1 over 1 minus w to transform the logistic equation to dw dt equals negative w. Expressing y in terms of w using a negative index, y is equal to 1 minus w to the power of negative 1. Now by the chain rule, dy dw is equal to negative 1 minus w to the power of negative 2 multiplied by the derivative of 1 minus w, which is negative 1, and that equals 1 over 1 minus w all squared. Now dw dy is the reciprocal of dy dw, and that equals 1 minus w all squared. Now we're going to treat this as a related rate of change. That is, dw dt is equal to dw dy times dy dt. And that equals 1 minus w all squared times y times 1 minus y, where y is equal to 1 over 1 minus w. Substituting 1 over 1 minus w for y, dw dt is equal to 1 minus w all squared times 1 over 1 minus w times 1 minus 1 over 1 minus w. Combining these two terms together, that equals 1 minus w all squared times 1 over 1 minus w times negative w over 1 minus w. Multiplying all three terms together, that equals negative w times 1 minus w all squared over 1 minus w all squared. So this term will cancel with this term, so we get negative w. Therefore, dw dt is equal to negative w as required. Part 2. Using the solution of dw dt equals negative w, find the solution of the logistic equation for y satisfying the initial conditions. Apply separation of variables to the differential equation dw dt equals negative w. Multiply both sides by the differential dt and divide both sides by w to obtain dw over w equals negative dt. Integrating both sides, we obtain ln of the absolute value of w equals negative t plus c. Applying the initial conditions to find the constant of integration c, when t equals 0, y equals 1 over 4. Hence, 1 over 4 is equal to 1 over 1 minus w, which gives a value of w of negative 3. Therefore, the constant of integration c is equal to ln of the absolute value of negative 3. So the equation becomes ln of the absolute value of w is equal to negative t plus ln of the absolute value of negative 3. Raising both sides of the equation to base e, we get w equals e to the power of negative t plus ln of the absolute value of negative 3. Simplifying the right-hand side, we get w equals negative 3 times e to the power of negative t. Now y is equal to 1 over 1 minus w. So substituting negative 3 times e to the power of negative t for w, we get y is equal to 1 over 1 plus 3 times e to the power of negative t. Part 3. How long will it take for the fox population to reach 3/4 of the island's carrying capacity? Solve for t the equation 3 over 4 equals 1 over 1 plus 3 times e to the power of negative t. By cross multiplication, the equation becomes 3 times 1 plus 3 e to the power of negative t equals 4. Dividing both sides by 3, we get 1 plus 3 times e to the power of negative t is equal to 4 over 3. Subtracting 1 from both sides of the equation, we get 3 times e to the power of negative t is equal to 4 over 3 minus 1. Dividing both sides by 3, we get e to the power of negative t is equal to 1 over 3 times 4 over 3 minus 1. Taking the natural logarithm of both sides, we get ln of e to the power of negative t is equal to ln of 1 over 3 times 4 over 3 minus 1, which becomes negative t equals ln of 1 over 3 times 4 over 3 minus 1. Multiplying both sides by negative 1, we get t is equal to negative ln of 1 over 3 times 4 over 3 minus 1, which equals negative ln of 1 over 9, which equals ln of 9, which is approximately 2.2 years correct to one decimal place.